Okay, recorder is on, and I will start with a reminder to self, because I can keep forgetting to do things that I should do, so I have to, send myself a reminder. Okay, go over solution of the homework assignment. All right. So let's do that first. Okay, your homework assignment that is due today is called Drive. There's a new homework called Drive and Steer. Okay, so we'll talk about that one too. It's a very minor, change to the program that you already have, but it does require one extra concept to get it to work. So what I'll do is I'm going to look at the homework assignment that we had before, and let me go get started with the App Inventor website. So I'm still using the old interface or the old website because the zip file is only going to work with App Inventor 1.0. If you try to upload it to App Inventor 2.0, it doesn't work. It will complain, oh, I'm expecting a file with the AIA extension. The zip extension is not going to work with the new version of App Inventor. So we'll still be working with the current or the old version of App Inventor for the time being, at least for this homework assignment. Okay, so here's my website here, and I have quite a few projects. Let me go back to my project view, and what I want to do is to do the homework assignment just the way that you would have done it too. So first thing I have to do is to right click and download the zip file. Okay, so we'll go ahead and do that. Right click, save link as. I'm using Google Chrome. So depending on which browser you're using, it might say something that's slightly different. I'll save it to my temp folder, and it's a tiny little file. Doesn't take much time to download it. And then I go back to App Inventor to re-upload it. So I can go to More Actions and say Upload Source, pick the file to upload, which is drive.zip. And it says it already exists, cannot create another project of the same name. So if you encounter that problem, the easiest solution is to rename the zip file to like drive 3 in my case, because I have a drive 2 already. So that's exactly what I will do, is to go to the folder that has the zip file, and just rename the file itself to a different name. So I'm going to rename the file to drive 3, and then re-upload. So upload source again, drive 3 this time, and the file should upload without any problems. It's refreshing, and now we have drive 3, and it opens it up also by default, which is nice. Are there any questions up to this step? I'm just redoing the homework assignment, okay, just to make sure that you guys have the solution to this homework assignment before we start with the next homework assignment. Alright, so now that we have the homework assignment opened up as a project, we'll go ahead and start with our blocks editor. And depending on the browser, you may see something that is different. On some browsers, it will open up Java Web Start automatically. On other browsers, you might need to click on the file itself to start Java Web Start. It depends on the browser, your computer, your operating system, and many other factors. Any questions? Questions? All right. So now we have the blocks editor open. It comes with a lot of code already, so that's okay, not a problem. Now getting back to the homework assignment. So what you want to do is to use any program to draw a card, download an image of one, and if you have an image, so you should have an image file at the end of this step. Upload the card image file to the project as a resource, and then you want to specify the sprite, that is corresponding to your car. So I'm going to do just that here. You don't have to make it very fancy. If you want to, you can just do what I did last time. I'm pretty sure I showed you guys how to do it last time. So I'll just go for NASCAR top view, and then go for images. Okay, so I think last time I picked this one, and I can pick a different one if I want to. It doesn't matter which one I pick. Here's another one that's nice. Okay, so I'll just pick the same one as I picked last time. So I'm just going to pick this one here, go to View Image. So that will give me the entire URL of the image, or I can just right click here and say save image as. So that will save the file as a particular image. I'll save it to the temp folder because I won't need it very long. So I just click save.
Last time it was moving in reverse.
Oh, that's right. Okay, we'll fix that. Okay, so if I want to fix anything, I can pick a whole bunch of different programs to do it. The one program that I like the most is called the GIMP, which stands for the GNU Image Manipulation Program. It's really quite useful. I mean, I cannot say it is as good as a Photoshop. It's not as good as Photoshop, but for most things that we do, okay, for 90 or 95%, depending on whether you are just a normal end user or you are a publisher who is trying to publish something, it will do most of the things that we need to do with images. So now we have the entire image here. So as pointed out, it is pointing in the wrong direction because 0 degrees in App Inventor is pointing to the right hand side. Okay, so if I upload this image and call this 0 degrees, it will be driving backwards. Okay, which is still okay. I mean, if you upload an image like this and it's driving backwards, I'm not going to take any points off. But since I'm doing the homework assignment as myself here, I want it to look nice. Okay, so this is what I'll do. So I'll turn it up. I will rotate it around. Okay, so I'll go to image here, and then I'll go transform, and it can rotate 180 degrees. So now we have 180 degree of rotation. And if I want to waste time a little bit, I will change out Microsoft to open source and or Linux or something like that. But since the image will be downsized to a really tiny little sprite, all of that stuff won't be visible anyway. So I'm good with this. The other thing that I would probably do is to get rid of the background so that when it's driving around, it's not going to cover up the background in the application. And that is a little bit, that definitely is an extra thing, but I would do it anyway. So I will go to transparency and add an alpha channel, which is the transparency channel. And then I will use a selection by color or selection by region. Selection by region is fine. Okay. And I can select this portion here and then just delete it. You see the checker pattern in the background? That means that portion is now transparent. If I put this image on another image, that portion, the portion that is checkered, will now appear to be transparent, and the background will show through. Okay. All right. So I think I've done enough work with this one. So time to re-export it to a PNG file. So I'll just simplify the file name here and say NASCAR. And I will change the extension to PNG. The reason why I have to change it to PNG is because JPEG does not save a transparent layer. It doesn't have the ability to store and say, oh, okay, this portion of the image is actually transparent. But PNG does have the ability to do that. So I'm going to save it as a PNG file. Click export. And it will ask me about these extra parameters. It's saving background color, which in this case is transparent. Save creation time, all of this stuff is good. Compression level all the way to the maximum, so it's not going to be a huge file. So now I'm done with the GIMP. I can actually go ahead and stop and get rid of the GIMP. I don't need to save any other changes, so I discard changes, and now I can get back to App Inventor. As soon as I get back into App Inventor, I go to Upload New. Go to the file, where the NASCAR.png file is located, and then click Open, and then click OK. So this will upload the NASCAR image file to the App Inventor project. And now that we have that, I can now click the sprite that is actually going to be representing the car, which is image sprite car, sorry. And then we can now go to Picture, and then pick NASCAR.png. And then click OK, and you can see that it's a little bit too big, okay, as a sprite. Okay, that's okay. We can always resize it. According to the instruction here, we want to resize it to 20 by 15 pixels. Okay, so we'll go ahead and do just that. We'll resize it to 20 by 15 pixels. Oh, that's the XY location. Sorry, it should be the width here. So 20 by 15. All right. So now we have a tiny little car instead of the huge car that we had before. Are there any questions about this particular step? Okay, no questions. All right. So we are now done all the way up to step 3 in the homework instructions. Step 4 is not really a step. It's just saying, forget the bouncing ball. It's going to bounce around, but it's okay. We don't care about that. Make the car go at a speed that is proportional to the position of the pedal. Okay, so it's going to be the same way as you drive. When you press on the pedal, a lower position means you're going to have more gas and the car will go faster. Okay, you don't have to simulate the acceleration effect. So it's the pedal position directly will change the velocity of the car, how fast it's going. Okay, scale the pedal so that when it is floored at the lowest position, the speed of the car will be 5 pixels per second. Okay. Yep.
Do you care how granular the speed went up? Because I think I did mine at like 5 stops. It's like
It will always. It doesn't always have 5 stops, but 5 stops it would be fine. I mean, 0, 1, 2, 3, 4, 5. That would be 6 stops actually. Yeah, that would be fine. Yep. All right. When the car hits an edge, just make it bounce using the bounce method. Okay. So this is what I need to do next. Okay, going back to App Inventor, there's not much I can do, on this part here. Okay, I'm going to keep the same interval, the same heading, the speed here. I'm keeping it the same, which is the initial speed. What I will do is to go to the blocks editor here, and then we'll start to do something, about the pedal, because the pedal position is going to change the speed of the car. Okay, so I'm going to locate the portion of code that is already dealing with the pedal, which is this one here. Okay, when canvas accelerator dot drag, okay, because I'm dragging the accelerator pedal inside that particular canvas, and this is where the processing is actually being done. So what we want to do is to say, if the pedal itself is dragged, okay, so we want to add some code right here inside this conditional statement and say, okay, now how do we change the speed of the sprite accordingly? Yep.
I just noticed there's also this other method where box sprite pedal drag would dropping the same code in there.
It would do exactly the same thing. Yeah, it would do exactly the same thing, except you don't need the conditional statement. Yep. This is a little bit more general because you can drag anything within the canvas and it will trigger this one. The other one is specific to a particular sprite, so I can use either one. Okay. So what we want to do is to associate some code here that will get to do what we needed to do. All right. So which property do we have to modify, or whose property are we modifying when we want to change the speed of the sprite? The question answers its own itself. Yep, exactly. Because we want to change the speed of the image car sprite. So image car sprite is the owner of the property that we need to change. So that will be under my blocks, and it will be under image sprite car, which is here. So you look at all of these things and you say, which one will change the speed of the car? Okay. So you scroll down a little bit, and then you can start to see, enable, heading, height, interval, picture, rotates. It is speed. Okay. The first one allows you to refer or read the speed of the sprite. The second one allows you to change it. Okay. So we'll go ahead and change it right here. Obviously, this is not done because I need to attach something to specify the new speed. Now, I want the new speed to be proportional to how far it has been pressed. Okay, so that means I have to think about, okay, what is the range of numbers that I'm dealing with? Okay, let's take a look. So what we'll do is go take a look at the design view itself. So we'll go ahead and take a look at the design view here. We're basically focusing on this part here. you can see the paddle is right here at this particular point, and the Y position is 0 at this point. Now, if you just kind of drag it around here and drag it all the way to the bottom, now you can see the position is 122. So that's how you can get an idea of what would be the range of values that you should use when you specify the range of the pedal. So it can go from basically 0 to 122. After you do this, you can always just 0 X and Y back to the origin. Okay, so we're looking at a range of value from 0 to 122, but we want to scale those values to 0 and 5. Okay, so how do we do something like that? Let's go back to the blocks editor here. Well, it seems like we need to do some kind of math. Okay, so what kind of math are we going to do? We want to scale everything to 5 pixels, 0 to 5. But the actual position Y can go from 0 to 122. And I know somebody's going to say, but I can drag it beyond 122. Yes, we'll deal with that next. Okay, but the first thing we have to deal with is the simple one. Okay, what will get you all the points that you want to get in this homework assignment. Okay, how do we scale something? Well, let's take a look at built-in here. It has math functions. Which one do you think will be helpful? Multiplication is going to be helpful. Okay, so we'll do a drag and multiplication here. And I think one thing is going to be really helpful is actually the position of the Y position of the pedal itself, which is already up here. So I'm going to do a Control C, Control V, just copy and paste it. Okay. What else do you think is going to be important? That 122 thing seems like it's important, and then the 5 pixels seems to be important as well. So we have a 5, we have a 122. What are we going to do with it? Well, you have to think about this Y position of the pedal position. What is the range of value for this Y here? It will go from 0 to 122, right? When it is at 122, what is the velocity that we want? What is the speed that we want? 5. Okay. When this is 0, we want the speed to be 0 itself. Okay. So it seems like in the other part of the multiplication, we need something else. We need a division. And then the division will involve 2 numbers. Okay. The first number is going to be the top speed that we want the sprite to go, which is at 5 pixels per period. And then the second number is going to be 122, which is the full range of the number of pixels that the pedal can travel. So we now specify 122, which is really close to the default number 123. Okay, and that's it. Okay, this is how we can scale the position of the pedal, the Y position of the pedal, to the entire range of 0 to 5. Okay. So now I think we're ready to give it a try. Okay. So we'll go ahead and go back to, oh, no, take it back. We'll start a new emulator so we can test it inside an emulator. Are there any questions at this point? Yep.
Where did you explicitly define the range of
Say again?
Where did you explicitly define the range of the accelerator?
What if you explicitly...
Yeah, you can define.
Accelerator.
You can explicitly define that. I
I
mean,
defined it as 125.
oh, that would be
I
fine.
was wondering where you got
For the accelerator height minus the pedal height.
Yep, you have to minus the pedal height.
Yeah, wasn't that 150 minus 25?
It's probably around there. Okay, this is the canvas itself. The canvas has 150 pixels, and then the pedal is 25, so it should be 125. So if I specify Y to be 125, it does seem to be clipped a little bit, as opposed to 122. You can see the edges around it.
But that display is not very active.
Oh, thank you.
Does not represent what's actually displayed that well.
Oh, okay. So, if it gets close, it's okay. All right. so now we have the emulator up and running, and then we'll go back to here and say connect to the emulator, which will automatically upload the program. So this will get almost everything done. The last part, that you need to do is like really easy. Okay, it's like a 10-second kind of job. Once you know where to look and how to do it. All right, so we'll go back to the emulator and take a look at the application the way it is right now. All right, so here's my little car, and so when the pedal is all the way down, it's going at about the same speed as the sprite, the ball, and when I push it all the way back up, it stopped. If I press it down again, it's going fast again, and now it stops. Okay, it doesn't bounce back because I have not specified the code to make it bounce. Okay, so the bouncing part is going to be something that we have to work on next. Okay, now how do we make it bounce? Well, if you look through the code that I have already included here, I really miss this feature. The new interface doesn't have this particular feature. I cannot like zoom into other things. Let's see here. We have right here. There you go. So when you look at this piece of code, which is already included when I give you the source file, this one is dealing with ball 1, okay, which is the little ball that's bouncing around. It has a particular event called edge reached. In other words, when the sprite is contacting an edge, this event will be triggered. In other words, I'm ready to do something, should I do something about it? This is basically how you attach code to do something when a sprite is touching, a particular edge. So you look at this code here and go, okay, tag said, ignore the ball, but can I borrow some code from here so that your sprite, the car sprite, knows how to bounce back when it hits one edge? What do you think?
Yes.
Nextdoor is always having fun. I don't know what they're doing. All right, so we'll go ahead and do exactly the same thing, except you don't even have to tweak the heading, right? You just say bounce back. That's all you need to do. So now we go to image sprite car. We take the event handler, which is edge reached, sorry. And it will automatically create a name for the parameter or the argument called edge. And then inside, all we want is really to go to image sprite car, pick up one of the blocks here, which is called bounce, and specify, which edge am I bouncing it from? Okay, which edge is being contacted at this point. You go to my definitions, then you go to edge 1, which is down here. Drag it here. That completes the entire program. Okay, so we'll go back to the emulator and see whether it is working or not. Okay, so now we can see the little car. Yep, it's bouncing back and forth. And we can also change the accelerator back to a 0, and then the car stops too. So do we have any questions about the solution to the homework assignment? No questions to the homework assignment? All right, so the next homework assignment, which is something that you have to start working on starting today, and you have 1 week to work on it, is to add the ability to steer the car around. Okay, so we want to be able to use the steering wheel, which is already active. The steering wheel has always been active since day 1. You can drag it and make it turn, but right now it doesn't do anything to the car. In other words, I can floor the gas, and it's always going to run into the wall and then bounce back. Okay, because the steering input is not used at all to determine the heading of the car. Okay, so your job for this new homework assignment is to make the steering wheel work the way it is supposed to. Okay, when you turn a steering wheel, the car should change its heading continuously. So it's not a one-time thing. It's not just when you turn the steering wheel, you change the car's heading according to the steering wheel. It has to be imagine you're driving a remote control car, and the steering wheel is the one on the controller itself. So when you're turning the steering wheel, the car has to keep turning as well. Are we doing okay so far with that concept? All right. So that's your new homework assignment. Before we talk about your new homework assignment, we'll go ahead and save the file right now. Okay, so I'm going to save this file. And there's a really cool feature called checkpoint. And what checkpoint does is it is saving your file, but it's saving it as a different, quote unquote, different project. So when I click save checkpoint, it's saving it as a particular checkpoint. I'll go ahead and say this is drive 3.1. Okay, nope, doesn't like that. It wants underscore. Okay, we'll give it underscore. All right. So now if I go back to my projects, you will see it doesn't appear as a. It only appears here, I suppose, as a checkpoint. Okay, I'll save it as a new one, so that way you can download it as the beginning, a starting point of your next homework assignment. Yep, it does save it, but I couldn't see it when I get back to my projects. Oh, there we go. It just took some time to get here. All right. So what I'm going to do, yep.
Then what's the difference between checkpoint and save as?
I cannot tell.
No.
So we'll go ahead and download source, which is a zip file here. I'm going to save it into my temp folder. And in the next homework assignment, the one that is active right now, I'm going to upload it so that you guys can use it as your starting point if you want to. If you think that your solution is working just as well, if not better, you can use your own solution. Down here, drive and steer. Because driving without steering is not necessarily a good idea. All right. So this is actually the entire description of your new homework assignment. The new homework assignment says using the solution to the previous assignment, which you can use, if you got yours working up and running just fine, you can use your own solution. If you want to use my solution, I'm going to upload it right now. I want to add steering to the driving. Okay, starting with this part here. Add steering to the driving. This means the position of the steering wheel, the angle of the steering wheel, should specify how the car turns. Again, download the source from App Inventor and upload it to Moodle. Okay. So what I'll do is I'm going to turn the previous assignment here into a hyperlink to link to the file that I just downloaded from App Inventor. So we'll go ahead and specify that. Drive 3_1, open, upload. Give it a title, solution, previous assignment, insert. All right. So now you have your next homework assignment. You have 1 week to work on it. Are there any questions at this point? Yep.
Car speed is 0. Change the rotate, even though the car stands still. You want us to?
Yeah, you want it to slowly rotate. Okay. Now I didn't specify how to scale it.
No,
so I
but
will
when the speed
specify.
is 0. When the speed is 0.
When the speed is 0, you should still make it change location. So it's kind of like driving a tank.
No, in real time you can't.
Right, in real life you cannot. You can change the position of the wheel so that next time when you start, it would go at a certain angle. Yep.
What's the maximum degree?
Let's go from 0 to 30 degrees. Okay. So we'll scale the entire steering to just 0 to 30 degrees. So it can be negative 30 or positive 30 because remember you can go in either direction. So let me just add that part to the assignment first. And change the description. Scale the angle steering wheel to -30 to +30 degrees. Okay, here we go. Okay, that seems like a pretty big challenge there because I never really talked about how to, change the steering. How do we change the angle on a continuous basis? Okay, that's something that we never talked about. So what I'll do is I'm going to show you a particular program that's really simple, but it does give you the one link that you need to get this assignment done. Okay, so we'll go ahead and look at one entirely new sample program, but it will answer the question. Okay, it will basically tell you exactly what you need to do. So I'm going back to App Inventor here, start a new project. Okay, this new project is, I'll just call that clock hand. Okay, second hand. That's kind of funny. It's not second hand as in used kind of second hand. It's second hand as in the hand on a clock that represents the second. Okay, so we'll see why. What do you think? This has anything to do with your homework assignment? Well, we'll take a look. Some of you already know. You're kind of smiling and go like, "Yep, I know exactly what's going on here." All right, which is good. Okay, so what we want to do is to use a canvas again. Okay, and we'll make this canvas kind of big. We'll make it 300 by 300. Okay, the size is not really that important, but it does make it easier to see it when it's large enough, like 300 by 300. So we'll make the canvas kind of big. And since I don't want to draw a new thing, so what I'll do is I'm going to reuse the images that I already have. So the NASCAR image, I'm going to import it here too. So I'll go ahead and say upload new media, specify the NASCAR PNG file, upload it. Okay, so now we have the NASCAR image as a resource, and then we'll drag a particular sprite into the canvas. Okay, remember a sprite can only go into an image. It can only go into a canvas. So we have an image sprite. I just stick it in here. We'll change the location a little bit later. First thing we want to do is to specify a NASCAR as the image of the sprite. And once again, it's way too big. But this time, I'm going to turn it into a kind of weird shape here. I'll make the x-axis a little bit larger. We'll make it like close to 300. Let's make it 250. And the y will make it very small. Let's make it 10. Oh, sorry, I made the same mistake again. I should have changed width instead of x and y. X is 250 and height is 20. And then we'll change the position of the sprite back to 0, 0 first, and then we'll center it again. All right. So here's my really badly deformed NASCAR. Okay, looks like one of those images from a sci-fi movie when something is getting sucked into a black hole. That's how it's elongated and stuff.
Looks like a marker. Looks like a marker.
Looks like a marker? Oh, yeah, it does. Okay, so I'll just kind of, center it a little bit, like right here. Okay, but when I'm centering, I'm only controlling the upper left-hand corner. So now we'll consider it kind of centered. All right. And I'm going to change the initial heading to 90 degrees because that's the usual way to start the second hand on the clock, which is 90 degrees. Okay. The next thing I need, now this part is important. Okay, how I shape this NASCAR, is not that important, but the next one is kind of important because what I'm going to do is I will go to Basic, and this time I'll drag and drop a clock. Now, but the clock is not visible, so how is this even going to be helpful to me to display, the second hand when the clock itself is not visible at all? Well, we'll take a look at some properties of a clock. When you look at the properties of a clock, it has these three properties only. Okay, the first property is timer always fires. What is a timer and what do we mean by always fires? The second one is timer enabled. And then the third one is timer interval. We'll start with the interval. The interval, which in this case by default is 1000, is specifying how long does it take for the clock to give you a tick, basically. Okay, so in this case, the interval between ticks will be 1000 milliseconds. So this 1000 is in units of millisecond. 1000 millisecond is exactly 1 second. So that means for every second, it will give you a tick. The first option, which is timer always fires, means after 1 second, after 1 tick, it will restart the timer, and then after another second, it will give you another tick. And it's going to be endless, okay? So it will go like tick 1000, tick 1000, tick 1000. It will keep going indefinitely. The second option, which is timer enabled, is simply an enable-disable kind of thing. If you uncheck this box, then there won't be any ticks. If you enable this box, then it will happen again. Every 1000 milliseconds, every 1 second, it will give you a tick. Are we doing okay so far? Okay. Now, when you go to the blocks editor, you will start to see something a little bit interesting, because if you go to my blocks, you see all the usual stuff, but if you click under clock 1, you will start to see what you can do with the clock. It only has one event handler. The one single event handler is clock1.timer. Every time it quote-unquote ticks, the timer goes off and this event happens. So whatever code you specify inside this block here is going to execute exactly once per second. Are we doing okay so far with this? Right? So what do we want to do with this particular program? I want that hand to tick, right? To like the second hand on the clock. So for every second, I'm going to do something about my image sprite. I will change its heading so that it is, let's see, every second is how many degrees? How many seconds do we have in one full rotation? Once, wait, okay. With a normal clock, okay, how many seconds is in one full revolution of the second hand? 60 seconds, right? And in terms of degrees, how many degrees makes up one full rotation? 360. So every second translates to how many degrees?
6.
Exactly 6 degrees. Very good. So we want to increment the heading by 6 for every second. Okay, so this is exactly what we'll do. We'll go to the math block here, and we need an addition. And then we need to go back to my blocks, go back to clock 1, refer to my current heading, okay, the heading that I'm currently using, which is down here. Nope, sorry, it's my sprite here. So go to the sprite, go to my current heading, and I really just need to add 6 to it for every second. So I need to specify a number and just make it 6 here. And that will basically, for every second, for every tick, the heading of the NASCAR, but now turned into kind of more like a hand on the clock, will move by, rotate by 6 degrees. So 6 degrees, 6 degrees, 6 degrees, 6 degrees. Okay? So we now want to see, is that really what's happening with the app here? And it's turning in the wrong direction. And it's complaining because the number of degrees is off, out of the range. Okay. Okay. But it seems to be working a little bit before it crashed out. And I don't need to start a new emulator. It works just fine. So I can close this one and reuse this one. I just need to reconnect. It will crash again, but we want to see what happens right before it crashes. Okay? And obviously it's moving in the opposite direction because the hand second turns in a clockwise fashion, and now it's turning in a counterclockwise fashion.
Just put a negative there instead of a positive.
Yeah, but there's a reason why. It's because when we look at heading, it's actually in a counterclockwise direction. App should be running. It thinks it's connected. But it's not interacting. I think it has to do with me starting the other emulator. I found the SD card is actually persistent. You can save something to it if you want to, but the problem is I can't install apps from outside. You can use ADB to install an app to it. Okay, so you can see it's moving in the opposite direction. Obviously, that's an easy one to fix, but it will crash at some point. So we'll go ahead and take a look at when it's going to crash. So right now it's at it started off with 90, so now it's at 180, and it's getting to 270. And then it's going all the way to 360. So when it points to the right hand side again, it is 360. And now it's going beyond 360. And it's getting to 360 plus 90. No, it will crash. The number can only take it up to a certain range. That's the problem.
So it seemed to crash earlier. First time.
No, I think last time we had it running in the background for a while before it crashed. I think 2 revolutions is probably as much as it can go, and then it will not work after that. But the point is, at some point it will crash, okay? Because the number of degrees can only be up to a certain point for the heading, okay? So now the question is, how do we make this not crash, when we keep changing the degree? And if you make the steering wheel turn at a certain angle, your car will be running in a circle. But the heading of your sprite, according to this code, will just keep going at a certain, will keep increasing. And we want to wait until this this thing crashes. But the question is, when it does crash, how do we handle it? Okay, is there a way for us to avoid this thing crashing? Okay, so there are several things we need to talk about as this keeps running. The first thing we have to know is, in App Inventor, the heading is like this. Okay, this is the center of your sprite. And when it's pointing to the right-hand side, it is considered 0 degrees. Are we doing okay so far with that? Okay, we're all okay with that? Okay. A positive rotation means it is rotating in a counterclockwise fashion, and a negative degree means it's going in the opposite direction. Is that part okay? Now, your homework assignment is not a clock app, so you don't have to invert the sign at all. When your steering wheel is is steered this way, you do want the car to change its direction in that direction. When the steering wheel is in the opposite direction like this, you want the car to steer in the opposite direction. So you don't have to flip, the direction at all. The question is, what if this is, going exceeding a certain range? What would be the useful number of degrees in a full revolution? This is 0 degrees. At this point, it is at 90 degrees. At this point, it is 180 degrees. At this point, it is 270 degrees. And when it gets back to 0 degrees, it is also considered the same as 360 degrees. It is also considered the same as 720 degrees, and so on. For the same reason, 270 degrees is actually equivalent to negative 90 degrees because it's the same way as rotating counterclockwise by 90 degrees. Okay? Doesn't seem to want to crash this time. It just keeps going. So maybe it is something else that we did. Yep.
So for the project, the wheel, like one full revolution equates to 30 degrees of the car.
The steering wheel itself can only go negative 180 to positive 180 degrees. So you want to scale 180 to about 30 degrees.
Spins all the way around, doesn't it?
Hmm?
Spins all the way around.
It spins all the way around, but if you look at the actual heading, it doesn't actually spin all the way through. It has to do with arctangent 2. Arctangent 2 can only return a number that is between positive 180 and negative 180 degrees. So that one is always guaranteed to be within the range of negative 180 and positive 180 degrees. Okay, so it doesn't seem like we're running into that problem here, so that's okay. So I guess we don't have to handle that particular issue of having the rotation to exceed a certain range. So I'm going to leave it up to you guys to decide how this particular example is going to be helpful with your homework assignment. Okay, yep.
Put a watch on the heading.
Okay, I can do easily that. You think the heading itself is resetting itself? Right, that's easy enough to do.
You just right click on the variable right there. Watch.
Nope.
No, it's going up.
It's going. All it has to do is do a mod 360 to get to a number that is in range. So I'm not quite sure why it crashed last time because we definitely have waited enough time.
Maybe it just glitched.
Could be a glitch. Yep. Or maybe it's something that I did while it is running. All right. So are there any questions at this point? Okay, there's one more thing I have to specify in your homework assignment to basically make it so that you don't have to think about that portion because it's going to be specified. Okay. So just one more thing to specify, and then we'll be moving on to lists, which is a really, really interesting topic. The heading should update every 100 milliseconds. Okay? That part is kind of important because what it does is it's telling you, how often you have to adjust the heading of your little card in the application. So it's going to be updated at about the same rate as it can move on the screen because it is moving on the screen, every 100 milliseconds. So I want the rotation to also be 100 milliseconds due to the steering wheel. Are there any questions about your new homework assignment? I think you have all the necessary pieces already. Yep.
What about synchronizing the?
There's no way to sync it. There's no way. There's no way to sync
Can't get the current
it.
time.
Hmm?
Can't get the current time.
You can get the current time, but you don't know when it actually updates its location due to the sprites its motion.
Oh, I was just thinking because through every cycle there may be a different amount of time between every clock execution,
Mm-hmm.
and it may become unsynchronized over a period
Oh,
of
it
time.
will get out of sync. So you will see your sprite, rotating when it's not moving, and then it will move, and then it will rotate, or it might move and rotate at almost the same time.
But I was just thinking, is getting the current time,
Mm-hmm.
preferably in milliseconds, then finding how much time is left to the next second, then update the interval, and keep on doing each time.
You could do that, but it will still not sync because the sprite itself is not synchronized.
I mean, yeah, it won't display maybe
Mhm.
synchronized, but it'll keep it within range. It won't
Oh, I
just,
see.
just slightly go off.
It won't drift.
Yeah.
Nah, you don't have to worry. Don't worry. Don't worry about it. Just a basic timer, set it to 100 milliseconds. You're good to go. All right. Any other questions? No other questions? Okay. If there are no other questions, if you have any questions, go ahead and ask me. Yep. Go ahead.
Like some of the parts of the implementer are really long. Can you like turn like a bunch of the blocks into like maybe like something that you call one function and just call that one block?
Ah, that's a good idea. Okay, the whole concept of a function. Yes, you can turn something into a function. The way you make a function, for those of you who want to use this feature, is definitely optional. You just go to definition, and then you have two kinds of functions. You have procedure with result, which is conventionally what we call a normal function in C that has a return value. And then we have just a procedure that has no return value, which is a void function in C. So you can use one or the other. If you define a function, you drag one of these blocks out here, you can change the name procedure to the name of the function that you want. Okay, so you say, function f1, and then you can go to, let's see here, under definition, you can go to name here. You can now define names for your arguments. So these are the names that you have to refer to inside the block of the procedure, and that will be referring to the argument. And the other one that has a return value, you can basically specify a return value, which is one of the sockets, in the block, so it will return that particular value. Now, I would not spend too much time on App Inventor 1 when it comes to procedures because it has no local variables. When you start to write subroutines and it has no local variables, you'll be forced to use global variables. But when you have one subroutine calling another subroutine, then you can run into problems because if they both refer to the same global variable, then the subroutine that you're calling can trash a variable that you are using, right? The caller is using. So that's why in App Inventor 1, I would not go too far with procedures because having one procedure calling another procedure can end up with really bad results because of the lack of local variables. Okay. And that's why it's a good idea to start to talk about App Inventor 2, which has a lot of new advanced features that will fix all of these problems. So are there any questions before we continue to move on to App Inventor 2.0? So I'll talk about how to get there first, and then we'll talk about just navigation-wise, it's a little bit different from App Inventor 1, but I think it's worth the trouble. Okay, so we'll go ahead and take a look when everybody is ready. So are we good to go? Okay, all right. So I can keep this one up. I mean, it doesn't interfere with App Inventor 2. So we'll go back to here, to my website here, and I sent a note over the weekend already to everybody, which is called the new version of App Inventor. And we'll go to there because it has a link to, it's called newblocks.appinventor.mit.edu. So I'll just go ahead and go there. The two app inventors, App Inventor 1, which is what we are using in this class, what we have been using in this class, and the new one, they're not connected in any ways. Okay, so they have different cookies, they don't interfere with each other at all, and you can start both at the same time if you want. So when you start on the second one, it will go through the same process and ask you to sign in. So you just have to sign into a particular Gmail account, including the school account here. You just click allow, and it will get you onto that page. App Inventor 2.0 also has a different companion. So if you're running this on an actual Android device, you will have to download the new companion for App Inventor 2.0. Okay. The other one doesn't work. Okay, the other one works with App Inventor 1, but it doesn't work with App Inventor 2. It's a handy feature, especially now that Chris has graciously loaned us a Wi-Fi router. So for those of you who want to program your Android device in this lab here, what you need is your Android device and also a Wi-Fi end device, because you need both the desktop computer and the Android device to be on the same subnet, so they will both have to go through the same router. Okay. If you have a laptop computer, you don't have to worry, because most laptop computers already have a G or N Wi-Fi card inside. Okay. But if you want to use the desktop computers in this lab, then you will have to bring in a wireless N or wireless G adapter so that your Android device and your desktop computer can stay on the same subnet. All right. So we'll go ahead, this is the really ironic part: Macintosh setup tools. The setup tools that we normally have to install on a PC with App Inventor 2.0, right now it is only available for Macs, which I think is ironic to the extreme. Because if you think about it, the iOS, which is from Apple, is the arch enemy of Android. So right now, the way it's set up means the only way to program Android is to use an Apple product, which is really, really kind of weird. But it's the way it is set up right now. The companion still works. Okay, you can still use Wi-Fi, for the programming part, or download the APK file, upload it, and then install with the APK file. That works as well. But it's kind of cumbersome, not handy. All right, so this is the new application. I have already written some kind of big application with it, and I really, really like it. So we'll go ahead and go to my projects here, and I have quite a few projects going on at the same time. Form data is the one that we want to go through in today's lecture, because I wrote the notes for that one already. Scorpion is one that I'm writing with my son. Is controlling a Lego Mindstorms. One of the projects with Lego Mindstorms looks like a Scorpion. Has different sensors and a stinger that can extend. So I'm writing that app with my son at this point. It's called Scorpion.
3 a.m.
3 a.m. Yeah. And then there's Study Buddy, which is also another app that I want to write with my son. It's basically an app that will help him out when he's doing his writing assignment or homework, math homework assignments and stuff like that. So we'll start with form data. Okay, and that's the one that is a little bit simpler, and it does illustrate how to use lists. Okay, and then the other thing we'll do is to go back to my notes here. Okay, I'm going to close this screen. We'll keep this one up. And scroll all the way to the current section here, which talks about variables and values, basically. And we're on to this portion called lists. This is a little bit complicated for people who are taking CISP 300 along with this class, or taking CISP 370 with this class. But I think the concept of a list is going to be so helpful in general that I think everybody should kind of get used to it. Okay. The first part, before you start, basically just talks about how you should upgrade to App Inventor 2.0, because it does have a lot of nice features. It's worth the trouble. It is still in alpha stage, but it's worth the trouble. The actual content of this particular topic starts here, and it starts with the discussion of what is a list. Now, up to this point, we have dealt with a lot of different types of values. We have dealt with text, okay, which is basically names and stuff like that. We have we dealt with numbers, okay, like the number of degrees to rotate. That's a number. It's a numerical value. We even talked about true and false. Okay, those are called Boolean values. It's either true or false. List is kind of like a fourth type, but in a way, it is also very different from the other three, because a list is what we call a composite type. It is one type that can include items or components of the three other types that we talked about, and also itself. In other words, a list can contain another list. Okay, so that sounds kind of awfully confusing. So what I'll do is I'm using this as an example here. We have a list. The first item of a list is a number. It has a value of 23. The second item has a text value. It is my name. The third item of the list is a list itself. Okay? It is called a sublist. That particular sublist has two items. The first item is a number, 100, and the second item is a Boolean value. It is true. And it also has, from the top level, it also has a fourth item. And the fourth item is a single number. It's a 43 as a value. Are we doing okay so far with the concept of a list? Sort of? Okay? So a list is a container, just like a folder is a container. When you are working with directories and files on just about any computer, can you create a folder inside a folder?
Yes.
Okay? And what about files? How is a file different from a folder? A file is not a container, right? A file is individual, and it cannot contain any other thing. It's the same thing with a list. Okay, a list is a folder, but all of the other values, Boolean, text, and numerical values, those are like files. They cannot contain any smaller components, and that's basically how we look at lists. Okay, just look at it as a folder. However, there is something important about lists that is not as important as folders. In a list, the ordering of items is important. In other words, we can refer to tag the second as the second item of the list. So if this is the list and you say, I want to get the second item of the list, it will return tag to you. Are we doing okay so far with that concept? Okay. App Inventor has many blocks to work with lists. Before we discuss the details of the blocks, let's figure out why it is used. Okay. All right, so are we doing okay so far with the general concept of a list? Okay, it's just like a shopping list. Okay, I'm pretty sure some of you have a shopping list where you have sublists, right? Can someone give me an example of a shopping list and tell me why on a shopping list you might have the concept of a sublist? Nobody goes shopping?
Different categories in the market.
Different categories, okay?
Like fruit or vegetables and fruit.
Okay, because they're located at about the same place inside the supermarket. So you want to group things together, because otherwise, if you put like vegetable at the top of your list, and you go through all the meat products, and then ice cream, and then you have another item that belongs to like fruit items, then you'll be walking all over the supermarket. Some people like that, but most of us want to get done with our shopping as quickly as possible. So you might have a list that has big items, right? A list that has vegetable and fruit as one subcategory. You have dairy and butter as a subcategory, and cheese as a subcategory. You might have frozen food as a third category. Within the top category, which is let's say frozen foods, okay? Within that category, you might have ice cream, you might have TV dinner, you might have other types of items that you find at the freezer section in a supermarket. So that becomes a sublist. It's the same way here with a regular list in terms of programming. A list can have multiple items, but these items can by themselves be lists as well. Then you can have a list, sublist, sub-sublist, and so on. Just like with a folder, you can have subfolder, sub-subfolder, and so on. Are we doing okay so far with these concepts? So far, so good? All right. Now, the applications or the use of lists, the first one, just illustrates, one thing that you might want to do. It's kind of advanced in a way, but at the same time, the app itself, to get this done, is actually pretty easy. Now, when you're dragging in the canvas, okay, in some cases, you can process the drag as it happens, okay? Especially when you want to draw something on the canvas, you can just, say, I want to connect lines between the dots of a drag, and that's it. I mean, that's pretty easy to do. On the other hand, there are certain types of processing that you cannot do, quote unquote, in real time. In other words, you cannot do the processing as the drag events happen. For instance, if you want to do any type of gesture recognition, maybe the processing of the gesture recognition is going to be too compute intensive. There's no way you can actually process the entire thing as the drag is still happening. So in those cases, you might want to save the drag locations first and then process that later, because then you have all the time in the world. Well, not really all the time in the world, but you do have more time to process the drag event and say, oh, okay, if I drew a circle on the canvas, that means I want to do blah. If I drew a diagonal line, that means I want to do something else, and so on. So you can recognize the gesture using some post-processing after the fact. But in order to do that, you have to remember the locations of all the points during a drag event. Okay, and that's basically what the first example is. The second one is to track motion, which means you take your cell phone, and you say, let's say you want to do a dead reckoning, which is a way so that you can find out how far you have gone in which direction. Okay, so basically you can say, okay, start the application, so that without even GPS, okay, you would be able to walk around a little bit and still figure out what was the path that you took when you walked around. Yep.
What's that called again? What's that called?
It's called dead reckoning.
Dead reckoning?
Yeah, DEAD dead, and the reckon is RECKON reckoning, RECKONING. It's a very specific term applicable to robotics and also anything that requires navigation that does not have an external reference signal like GPS.
What sensors does that rely on?
Accelerometer. That's the only thing you need. And also in the good old days, they also have a gyroscope, which is basically a top that is spun by an electric motor, but it is suspended in a very precise axles, on very precise axles. So the top, once it's spun, it doesn't want to change its direction, right? So it's the same thing here. So the top inside a I just forgot what I said. What was the name of the device that contains the top? Gyroscope, that's it. So the gyroscope can give you the orientation. At any particular time, you can tell your orientation relative to the initial orientation when you first started to spin the top inside the gyroscope, right? Now combining that with accelerometer, which is measuring the acceleration in 3D space, now you can actually use mathematics, mostly just integration, to figure out where you are, because speed or velocity is an integration of acceleration, and then displacement, which is distance, is an integration of speed or velocity. So once you have direction and also the quantity of acceleration, then you can actually tell exactly where you are without any external reference. That's actually how airplanes used to locate themselves, is to use the stars and also just a gyroscope before the days of GPS. Yep.
How reliable is a gyroscope or a on-chip version and accelerometer? How accurate is it? Because I've seen a gyroscope or an accelerometer seem to sort of, it's okay at first, and it sort of just slightly,
it would drift.
Yeah,
it can drift. It depends on the accuracy of the chip itself. So it depends on how you process the information too, because sometimes you can do post-processing on the data and still be able to work with numbers that are relatively precise. So it all depends on the hardware, the precision of the hardware. Now, the accelerometer on these devices were never intended for dead reckoning for that purpose. So I would imagine they're not really that accurate. After a while, they would drift enough that you'll be kind of far off from where you started off with. But on airplanes, they have high precision devices that can still be very useful for that sort of thing. Okay, so but that's another application. Basically, what you do is you turn on the app, and what it does is it's really just keeping track of the compass reading, accelerometer, reading, and a few other types of sensor reading. And then when you're done, you click stop, okay? And then the app will go through the entire list of data points, okay? Possibly including time and everything else. And it can give you a graph, a 3D graph, not just a 2D one, of where you have been and how to get back to the point of origin if you need to get back, and all without using GPS or Wi-Fi signals for external references. That could be a cool application. If you think about it, I mean, that could be a cool application because when you're inside a shopping mall and some other indoor places, you may not have GPS signals whatsoever. Okay, even the compass may not work. Okay, so what you need to do is just point the device, point your camera to a certain point to basically say this is my reference location and this is my reference direction. With enough precision with your other types of sensors on the device, you may be able to make an app that can track your location at any particular time. I think that's an interesting app, if it is possible. Okay, that depends on the accuracy of the sensors on your device. That's another application. There are other things that can also be very useful. If you read through this section here, at the bottom, I have some additional applications of why lists can be useful. So it goes all the way down here. Okay, so this one is kind of useful because when you want to save information, you can actually save an entire list all by itself. Okay, that means you can have one single variable within your entire app. But this one single variable is a list. If that list has 200 items inside with sublists and whatnot, you can use one single TinyDB store block to store the entire 200 items because it is actually considered as one single list. Now, when you need to restore all the data, when you restart the application, you just say, TinyDB, I want to read back this one single tag, and it will bring back all 200 items. Now, that is a much better approach compared to 200 global variables, and each one requires its own TinyDB block to save it. Am I kind of giving you guys a general idea of how lists can be useful? Because it's a composite. You can have items inside the list, and there's no limit other than the amount of resources you have on your, especially RAM resources on your device, of how big or how many items you can contain within a single list. Yep.
I don't remember if you said this before, but does TinyDB actually save the content to the device, or just
it does
in RAM?
No, it's stored as in permanent storage. Yep.
Is it kind of like a stack where you can't randomly access all of it, but you have to
You can random access. It's more like an array than a stack, because you can random access anything inside a list. You can also easily append to the end or insert in the middle. So a list actually has a lot of interesting properties that makes it, in a way, more useful than arrays. But it's not as efficient as an array because random access actually costs more time. But in this class, we're not going to talk about time complexity or how much time it takes to do a particular operation. But in terms of just in general how useful it is more useful than a general array. Okay. So that's the first thing that makes your list extremely useful is if your app requires storing any type of data and have to restore data, and it's not just a few items, instead it's a few like 10 or 20 or 30 items. Lists can come in very handy just for that purpose. Okay. Next. Can a list be passed from one screen to another? And the answer is, again, yes, affirmative. Now, this is also nice because there are only two blocks in App Inventor that allows you to pass information from a screen to a screen that you're starting. Okay? If you look up the blocks, it's called open another screen with start value. Is the one that you have to call or execute on the original screen. In the screen that is started, you can use get start value in order to get the quote-unquote parameter from the screen that is starting you. Okay, but it is a single value. Well, if it's a single value, it means if you're not using lists, you can either pass along a string, a text information, like a name or something like that. You can pass along a number, or you can pass along a Boolean, a true-false value. Okay, and those are very limited. Okay, but when you can pass a list, then you can pass 200 items as if it is a single item. So it is, once again, very handy. You can also do the opposite. When the screen closes, you can also use a list to pass values back to the screen that started the other screen. So let's say you have a configuration screen and you want to get back to the original screen. You can pass the entire configuration as one single list. Now that is really handy. Okay. Can a list of pairs be used in a URL request? And the answer is yes. Now this is particularly helpful for people who want to interface your app with a website. So when you are trying to update a website or query a website, you may contain multiple parameters in your query. Okay, so you might want to pass along product code, price, date, customer ID, and so on and so forth, to the website. You can do that with what we call a list of pair, or pair list. We'll talk about that in just a little bit. You can also save a list, single list, as a CSV, comma, separated value row. You can also save it as a table. Okay, if a list has sublists, you can also save it as a table, as a string, but you can also save it into a file. So that means, if you can present your data as either a list or a list of sublists, it is very easy to export it to a file, to a CSV file. So once you export it to a CSV or comma separated value file, you can now read it in Excel and process it in a spreadsheet. You can also import it into a database and use all kinds of tools inside the database to process your data. So that can definitely come in very handy as well. So that's why this one concept of a list is so useful, because it really opens up the door to all kinds of possibilities. Are we still doing okay so far? Okay, so the next thing I want to do is talk about what is a pair. Okay, what we consider as a list of pairs. Okay, so for that, I think using the whiteboard is probably the best thing to do. And I do want to talk a little bit about this before the end of today's lecture. I know I will be running a little bit over time, and I know exactly what to do to keep you here. And that's the row sheet. So pass around the row sheet and make sure you sign your name on it. Okay, so what is a list of pairs? Well, maybe it's this, right? One pair, two pairs, three pairs, and so on. A list of pairs. Now, nobody's getting it. Okay, you guys are all anxious to get out of it. Okay, a list of pairs looks like this. Okay. Okay, let's look at a pair first. Okay, a pair, as the name implies, has two items. So it's basically a list of exactly two items. The first item is a name, which we call a tag. So the second item is a value associated with that tag, and this is a pair. We doing okay so far? Now, when you fill in any type of paper form, you're dealing with pairs all the time, because you will have the tag may be called first name, but the value will be the actual data that the user enters. Okay, so this is one pair. The second pair may have a tag of last name, which identifies what is the value representing, but the actual value is, in this case, my last name. You might have another one to remember the phone number. So phone number is the name of the tag, which tells me what the value is actually representing. In this case, the phone may be 555-5555, like that. So now I have three pairs, each pair representing a tag and a value, a tag and a value, a tag and a value. What if I say, oh, you know what? I want to put all three pairs into a list. Now we have a list of pairs. Are we doing okay so far with that concept? Yep.
Isn't it the same thing as a key value pair?
Exactly the same thing. It is the same thing. So this part here is called a tag. It is also called a key. So it is exactly the same thing as a key value pair list. Okay. In different programming languages, it's called different names. It is also called an associative list or associative array. It's also called a hash in Perl. Okay, but they're all representing the same thing. This is nice in many ways because now the ordering of the pairs does not matter anymore. I can flip the order of these three pairs any way I want, but I will still be able to locate the first name because I'm no longer locating first name by its position. I'm now locating first name by its tag. Are we doing okay so far with that concept? In other words, it is kind of like TinyDB, except it is not in TinyDB. You store values by its tag name and its value. You retrieve items also by the tag, so you can retrieve the value. We doing okay so far? Kind of. Now this opens up, again, a lot of possibilities because instead of having 20 variables, individual global variables in your program, that you need to store to configure things and store configuration, you can use a single list that has as many items as you need to store the configuration data and whatnot in your application. And you can locate each one by its name. I'll just do one extra thing as the row sheet is still being passed around. Is it done passing around or is it still being passed around? Okay. All right, so we are halfway done here. I just want to point out one thing here by going to the new app inventor. The interface looks a little bit different when you click the blocks editor. It doesn't start up using Java Web Start, which is extra nice because it is now completely web-based. Okay, you don't need to have the Java installed for that purpose. So what I want to do is just to show you. I know the program is fairly complex. We're not going to have time to finish the whole thing today, but I just want to show you what you can do with lists. And if you scroll all the way down here, it has this one little block here that says look up in pairs, key, and then pairs, and the last block is not found. Okay, so this is really quite useful because it goes along with what we just talked about here. So with a single block, you can basically pass it a list of pairs, which goes into the second socket here, a key, which is also the same as a tag, and also a default value to return if something is not found. So it has to be a unique value that you can identify and say, oh, if I get this value back, it means the item is not inside the pair list. So with one single call like this, you can basically use one single list combined with the effect of a tag and be able to store any number of items in a single variable. Am I doing okay so far with the concept itself? Is that all right? Okay. It has a lot of applications. We have just gone through a few applications without actually showing you the code. The notes that I have prepared for today, which is, which I've already run out of time, actually has, code that you can write. Particularly if you go to the second portion. I know it's kind of. Okay, if you go through this example here, if you go through the example of a complex data structure, which is also called the form data, then it will talk about how to use a list of pairs in order to represent different data fields in a form. It can bypass some of the inherent limitations of App Inventor. Okay, because once you have a list, then you can start to have a unlimited number of items. So the only problem now is how do you go through each and every item to process it or to present it on the screen. Okay, so we'll go through this on Wednesday. So be sure to kind of read ahead of me because this is kind of like a thicker, more difficult technical section. But at the same time, I think the benefits of knowing how to use lists is tremendous in any type of programming.
So we're supposed to use App Inventor.
Yeah, with this one you have to use App Inventor too, because I have a subroutine here.
Because I don't have an Android device.
You don't have an Android device? I will try to figure out how to use the emulator combined with App Inventor too. So it's going to be, I tried some approaches last night and I couldn't get it to work. But with ADB, if you don't mind running some command line commands, I think we can get it to work. Yeah, so I think we can get it to work if you just run ADB on a command line. You can still install an APK file. So it'll be more cumbersome, but we can get it to work. So are there any questions? No questions? How many people are kind of familiar with these concepts already? Arrays or pairs. Okay, excellent. So you guys already know what you can do with it, and so we'll just talk about how to use App Inventor in this context. All right. So yep, go ahead.
In terms of lists, like is this speed? It's mainly speed, and then
It's not going to be very fast, especially with a list pair. If you compare the speed to access a variable as an individual variable, as opposed to the value of a list pair, the list pair method is going to be slow for sure, because a list is not indexed, which means you have to search through it linearly to find the item that you want to load. Most Android applications are not speed sensitive in that way. But the convenience that it buys you is great, because now we can easily expand the program and say, oh, you know what? Instead of having 20 configuration values, I have 30. You don't have to create 10 more variables. You just say, oh, here are the 10 more tags and the 10 more values, and then the way you store and the way you restore the configuration will be exactly the same, because it's one single item in your tiny DB. And when you pass information along from one screen to the next, there's no change, because you just pass the entire list along. So now they become 10 more items in the list, no big deal. There's no change in the interface between the screens. And that's why it's such a kind of game-changing type of concept when it comes to app writing. And it's something that you can carry over to a Java class, because the same concepts are present when you're dealing with Java, because this is not an App Inventor kind of thing. It is a general purpose program.
It looks like a Scratch.
It does. you can see the two projects are slowly
Merging.
Converging.
Yeah.
Yeah.
So that router
Yep.
is a wireless in router.
Uh-huh.
So should